location for activation record. So, where do you create this activation record? So, that is a question. Now, depending upon the language that you have, this activation record can be created in the static, stack or heap area. So, these are the three options that we have, where are you going to create this activation record. So, if it is created in the static area, that is the global area that we have. So, like we have seen that a program can have the global variable area. So, where that is called the static area. So, that can, apart from the static the global variable. So, it can also have this activation records, the area for activation records. Now, this early programming languages like Fortran, they used to have this activation record created in the static area. So, so this address of all arguments, local variables, etc., are preset at compile time itself, and to pass the parameters, values are copied into these locations at the time of invoking the procedure and copied back on return. So, there can be single activation of a procedure at a time, and recursive procedures cannot be implemented. So, let us try to understand what do we mean by that. So, I said that activation record, it has got it has got the entries like this return value, then return address, then the parameters that you are passing, and the local variables. Now, what this static allocation will do? So, we are looking into the static allocation. What the static allocation will do? So, it will fix up some entries. Okay, like if in a if I have got a program where at some point of time I am giving a call to procedure P1. So, this is say x equal to say P1, and then I am passing the values like say A1 and A2 as two arguments for this, and then this is the procedure P1, and there I have got the local variables say M1 and M2. Now, so if this is the code that is generated, this is the translated version of the object code that is generated. So, the some part of it is corresponding to the code of the program, and say this part of this file, the object file, is corresponding to the static. So, this is called the static location, that is the global variables are allocated here. So, some part of it will be occupied by the global variables, and some part may be allocated for this activation records. Like by analyzing this program, we know that at this point this procedure P1 is going to be called. So, we earmark a portion within the static area to act as the activation record for P1. So, this part is earmarked to be the activation record for P1. That is, whenever in my program from any point in the program, if I am going to make a call to P1 procedure, then these entries will be filled up here. So, the first slot may be for the return value, second slot may be for the return address, then there are two parameters that I am passing. So, this is for so this has got two values, say A1 A2, let us call them B1 B2. So, this is the space for B1, this is the space for B2, okay, and this is the space for M1 and M2. So, like that it has got. So, this part of this memory, so it is earmarked to act as the activation record for P1. Now, what the compiler will do at this point when it is generating the code for this procedure call. So, it will have the code such that this A1 is copied into this location, A2's value is copied into this location, fine. Then the return address is saved on, so the return address is this space is reserved for return value, this space is saved for the return address. So, this way we can do this thing. Then this M1 and M2, so they are for the local variable. So, when it comes to the local, when it comes to this code, so when it is doing a translation of this M1, some modification of this M1 M2, so they will be affecting these locations M1 M2 like that. Now, on return, so what will happen, it knows, the compiler knows that the return value is available at this particular address. So, it will be copying it to x directly. So, for this call, the return value will be available at this location. So, for this x equal to this p 1 etcetera. So, it will be copying the content from this location and putting it into x. So, that is how these static things will work. Okay. Now, for every procedure that you have in your program, so if there may be another procedure p 2 in the program. So, there will be another such frame created in the static area which will correspond to p 2. So, for every procedure call, for every procedure that you have in your system, so there will be a there will be an activation record created, and whenever a call is made to that particular procedure, this record will be filled up by the calling procedure, and the manipulations will be done on these variables on this activation record only, and after coming back this return value is again available in the activation record. So, from there it will be taken. So, this is how the static thing will work. Now, the problem that we have is that see, we cannot have more than one activation of P 1 simultaneously, because in that case if there is and somebody else from some other place is also allowed to call P 1 when this call is active, then what will happen is that this P 1 will get activation record will get overwritten. As a result, the execution will become erroneous. So, apparently it seems that why this should happen, because ultimately we have got a single processor. So, as a result, so there can be only one call at a time, but there can be situation like this P 1 may be a recursive procedure. So, within this this P 1 may be giving a call to P 1 itself with some parameters, say M 1 and M 2 plus 5. Suppose it does something like this, then what will happen? So, then this M 1 and M 2 plus 5, these two values will be copied onto B 1 and B 2. So, previous B 1 B 2 contents will be lost. So, it cannot return to the proper place. So, this all calculations will be lost. So, that is why this static type of organization, so of this activation record, though it is very simple in the sense that we know the size of this static section. Okay. So, so it is very simple, but it cannot handle complex situations by like say recursion. So, this is a recursive, is a P 1 being a recursive procedure. So, it cannot handle that situation. So, for the static allocation of activation record, so it only one procedure call should be active at a time. So, coming back to the point that we were discussing. So, it was there in the early programming languages like Fortran. Okay. So, this in Fortran you do not have recursion. So, there it was possible. So, address of all arguments, local variables etcetera, they are computed at the compile time itself, and they are we fix some locations for them, and the code is generated such that whenever a procedure call is made, the code is generated such that the parameters that you are passing. So, they will be copied onto this activation record space, and after it is over. So, they will be copied back from this activation record to the actual variables. So, that way if there is a change in the values of those variables within the execution of the procedure, so that will get reflected. So, what I mean is that suppose I have got this as the activation record for procedure P 1. Now, I am giving a call to this procedure P 1 at this point in the main program. So, I am giving a call to the procedure P 1 with the values like A and B. So, whatever arguments we have, so these values will be copied there. So, this value of A will be copied into, if this P 1 has this procedure P 1 has got the arguments x and y, and suppose this is for x and this is for y. So, at the beginning the value of A will be copied onto x and value of B will be copied into y, and once the procedure is over, then this x and y values are now modified due to execution of this P 1, and then this x value will be copied back to A and this y value will be copied back to B. So, this is this is a type of parameter passing which is known as call by value result. This is called by value result. So, at the time of calling the procedure, the values are copied to the parameters, and at the time of returning the parameters are copied, the final values of the parameters, so they are copied back to their original variables. So, this way so they will be copied back on return. So, this is called by value result type of parameter passing. And as I discussed previously, so there can be a single activation of a procedure at a time, because multiple activation will destroy the activation of this activation record content of the previous call, and so and recursive procedures definitely cannot be implemented. Okay. So, next we will be looking into other possible location for this activation record. So, on the stack area. So, can we create this activation record on the stack area? So, it is used in most of the programming languages like C, Pascal, Java, etc. So, they do create this activation record in the static area, in the stack area. So, as and when a procedure is invoked, corresponding activation record is pushed into the stack. So, activation record structure remains same as we have seen previously. So, it has got the return value, return address, then parameters and local variables, but they are not created in the static area, they are not created in the along with the global variables. Rather, when this procedure call will be made, one such frame will be pushed into the stack, and then the code that we will have within the procedure when it is referring to those parameters and local variables. So, they will be doing it from the stack, and when it is returning, this entry will be popped out. So, that will go out of the stack. So, this works well if local variables are not needed beyond the procedure body. So, it is like this. What I mean is that, so in the previous example, so we have got this procedure P1, and it has got say arguments, that is say int x and y, and then within that I have got some local variables a, b, etc. So, this activation record structure is fixed as we had previously, the return address, then x, y, a, b, etc., but they are not created on the global area or the static area. Rather, so as you remember that this program snapshot that we talked about, so it has got the code part, it has got this static part, and it has got this heap and stack simultaneously. So, this heap, the stack starts from the bottom. So, when a call will be made to the procedure, so if this is the main routine, at some point of time you are given a call to P1 with say values say R and S, then this activation record will be created onto the stack. So, this activation record is pushed into the stack, and here I have got this R and S copied at x and y, then this space for a, b, etc., and this code whatever we have. So, they will be referring to the locations that we have in the stack. So, that way the code will be generated. Now, after some time when this P1 is over, then what we will do, we will just pop out this block, pop out this frame from the stack. So, after this procedure is over, this local variables a, b, or these parameters arguments x, y. So, they are not visible, okay, because they are already deleted, they do not have any existence after this. So, if you do not need them, then it is fine. So, you can do it on the then you can do it in this fashion. But of course, what is the biggest advantage of this? The biggest advantage is that you can support recursion now, because now if there is a call to P1 at this point with the parameters say a and x plus y, then you can, so this frame is there in the stack. So, you can push another frame here which will be corresponding to the activation for this one, and when this call will be over, so this record will be popped out, but this record will remain in the stack. So, that this previous call, so whatever statements you have after this, whatever statement you have after this, so they will be executing properly referring to these locations that we have in this part. Okay. So, that way this recursive procedure calls can be handled very efficiently if you have got this stack type of realization. However, there are problems at some places, because a very serious problem that you have is that these local variables that we have. So, they are created in the stack, and you really do not know how many times this procedure P1 will be called recursively. Now, as I said, that is local variables, so they are also created in the stack. Now, suppose I have got this local, I have got an array here, say that is also an integer array, say AR, but its dimension is very high, say 10,000 by 10,000. Then what will happen? So, this array will get created onto the stack itself. So, this your activation record will now be very large, because it has to accommodate such a big array in it, okay, such a large number of integers in it. So, that will be a very big array. So, this activation record will be very large, and the situation will be even worse. So, if this P1 happens to be a recursive function, because now recursive procedure, because now every activation will have one such large set of integers created as local variables. So, as a result, what can happen is that this program while executing, so it can be running out of memory. Okay. So, there are some errors called stack overflow type of errors. So, that can occur and the program may misbehave. Okay. So, what is the solution? Solution is that you do not make these arrays local. Okay. So, you make this array global variable, so that this array will come to the static area, and they will not be created with every activation of this procedure. So, though it may or may not serve your purpose, like if you need that for every activation of the procedure I should have a new array, then this does not provide any solution, but many a time we just do it carelessly. So, we just make large local arrays. So, it is advisable that we do not do that, because if we do this large local arrays, so they will be created onto the stack, and as a result they will if this particularly if it is a recursive function or recursive procedure, then it will be invoked again and again. So, there will be large space occupied by these local arrays. So, there is a chance of stack overflow. So, we can just try to solve this problem by having this local arrays made global. So, putting them outside and putting them to the static part of the code. So, this is good, because we can have this recursion part implemented very easily. We can have this recursion part implemented very easily. For languages like Lisp, in which a full function may be returned, so activation record is created on the heap. So, this is another situation where, so here I was talking about creation in the stack. Some programming language like Lisp, so it will create it will return a full function as a return value of one function, like that. So, then in those cases activation record will be created in the heap, because then how many parameters it has to dynamically allocate variables and all. So, that can be done only from the heap. So, in that case activation record will be created in the heap. Okay. Now, processor registers, so they are also part of the runtime environment. So, because when a program is executing, so it has got the its processor registers are holding some of the variable values and all. So, that is also part of the runtime environment. So, they are used to store temporaries, local variables, global variables, and some special information. So, these are the purpose of this processor registers. Program counter is another very important register in the processor, that points to the statement to be executed next. So, that is also a part of the runtime environment. Then stack pointer, so that is also a processor register. So, that is also used to point to the top of the stack. So, that is also part of the runtime environment. There is a frame pointer which points to the current activation record. So, some of the processors, they will allow this frame pointer to be available. So, you can as a separate register. So, you can use it for pointing to the current activation record. Some processors will not allow this thing. Okay. So, in that case you have to dedicate some general purpose register to work as the frame pointer register. And there is an argument pointer that points to the area of the activation record reserved for arguments. So, these are the three supporting pointers that are needed for supporting these dynamic activation records one is the stack pointer, one is frame pointer, another is argument pointer. And as I said that it may or may not be possible that we may or may not have all these pointer registers available, and many a times. So, what we have to do is that we have to use some general purpose register to act as the as these registers. But however, so they also form part of the runtime environment. So, they are also to be taken care of. Now, if you look into the environment types, there can be two type of situation that you can find out. One is stack based environment without local procedures. So, where these local procedures are not supported, and we can have stack based environment with local procedures. So, without local procedure, as I was telling previously, so we do not have nested procedure definition, but with local procedure means we have got nested procedure definition. So, they have got so they followed in some block structured language like Pascal. So, you will find this nested procedure definition, whereas if you look into languages like C, nested calls are allowed, but nested definitions are not allowed. So, we will have to see like how can we handle this situation, both of them in runtime environment. First, we look into the simpler version, that is where we do not have the local procedures. So, all the procedures that we have, so they are global in nature. So, there is you cannot have a one procedure definition nested within another procedure. So, all procedures are global, and stack based environment will need two things, one is frame pointer, another is control link or dynamic link. So, in this case what happens is that we have got so we have got two things, one is the frame pointer that point to the current activation record to allow access to the local variables and parameters, and there is a control link or dynamic link that is kept in current activation record to record the position of immediately preceding activation record. So, we will see some example. Basically what happens is that, so you have got say one procedure, say from the main program I have given a call to procedure P1. Now, within procedure P1 there is a call to procedure P2. Fine. Now, while we are executing procedure P2, now which definitions are we going to use? Okay. So, if this is the body of P2, then what are the definitions that we are going to use? Now, depending upon the scope rules of the language, so it may be that it is static scoping. So, that is we are so P2 from which portion of the procedure we should take the definition that they are fixed. So, that is defined by the static nesting rules, or it may be it is a dynamic nesting rule. So, since at this point of time P2 has come through P1. So, if there is a variable x, so it may so happen that here it is referring to an x equal to something, and I have got a global x and I have got another x which is here in P1. Now, when I am referring to this x, so is it referring to this one or this one? So, that is the question. So, now if it is a dynamic situation, dynamic scoping rule, then it can tell me which x to follow. So, there I can have in the activation record one control link, so that can tell what is the preceding activation record. So, that way I will first search in the activation record of P1 and getting x there. So, when I am writing x equal to, so it will refer to this x. On the other hand, if I say that P2's dynamic link, so it is pointing to the global activation the global table, in that case, so it will be referring to this x. So, based on this activation record, so we can this control link we can find out like which variable definitions are going to be used. So, we will take some example and then try to explain. Say this is the situation, we have got this is a definition, like we have got the functions f and g, and from the main program there is a call to g, and so this is So, this is the situation. So, this is the activation record for main. So, main does not have any local variable. So, there is nothing here in at the local part. So, nothing, we cannot understand much here, but this x is a global variable. So, this x is coming as the static part. So, this is in the static area. Okay. Now, this activation record and then there is another x here. So, in within function f, which is called static int x1. So, this is another x. So, this x and this x, they are not same. So, this is a global variable and this is another x coming from the function f. So, this x from f, so that is equal to 1. So, that is the situation. And then so this is the snapshot of the program after main has called g, g has called f and f has in turn called g. So, main has called g, g has called f and f has called g from there. So, from here, so we have got this one, this m. So, we have got from f to g. So, the first call g x y equal to m minus 1. So, this m is getting the value. So, 2 has been passed. So, y is equal to 2 minus 1, that is 1. So, m is equal to 2. So, that is the parameter that I have passed. Then we have got the control link, return address, etc., and this is the local variable y. So, y equal to 1. So, that is the situation, and then there is a call to f of y. So, this function has been called. So, this activation record is pushed into the stack now. Okay. So, previously we had up to this up at the main routine, then it had called g. So, up to this much is created in the activation record, and then now this f has been called. So, this is the activation record for f that has been pushed, and in the activation record of f, so again we have got this parameter n. So, n value of n is equal to 1, and then because 1 we have passed 1 there. So, 1 is passed there, and then this is the static part, static int x is static. So, it has gone to the global part, global section, and this control link and returns. I will come to control link later. Then from here it has given a call to the g routine. So, from after this the activation record for g is created and pushed into the stack, and then this y equal to m minus 1. So, y becomes equal to 0. So, m was equal to 1. So, y becomes equal to 0. So, this is the situation. Now, this control links, they are actually pointing to the previous activation record that we have. So, from main, when I was calling call to g, so control link was pointing to main. Similarly, from g, when I was considering, so g was from g I have given a call to f. So, from f the control link is pointing to the g function, and from here from g the control routine is pointing to the previous one f. So, this is the situation now. The situation may change. So, as we go into further calls, and that may complicate the situation. So, here it is very simple. So, here you can say that the control links are not necessary, because I can just pop out the entries from the stack and that will be going absolutely fine. This happens here, but in more complex situation that may not be the case. Okay. So, we will see that in successive examples.